water wet? This seemingly simple question has sparked debates and curiosity among scientists and lay people alike. The crux of the debate lies in how we define wetness and whether water fits this definition. Contrary to popular belief, many scientists argue that water itself is not wet, but rather it has the ability to make other substances wet. The concept of wetness hinges on the interaction between a liquid and a solid surface. When we say something is wet, we often mean that it is covered or saturated with water or another liquid. In scientific terms, wetness is defined as the ability of a liquid to maintain contact with a solid surface. This definition implies that for something to be considered wet, it must have the capacity to transfer its liquid properties to another surface. Water, being a liquid, does not adhere to itself in the same way that solids do. Instead, its molecules are in constant motion, sliding past each other. This characteristic is what allows water to flow and take the shape of its container. When water comes in contact with a solid surface, such as a tabletop or a person's skin, it adheres to the surface due to intermolecular forces like hydrogen bonding. This adhesion creates the sensation of wetness on the surface. However, this does not mean that water itself is inherently wet. It is the interaction between water molecules and a solid surface that creates the perception of wetness. If we consider wetness as the ability to transfer liquid properties, then water does not meet this criterion when it interacts with itself. To illustrate this point, imagine a droplet of water suspended in midair. Without a solid surface to interact with, the water droplet cannot be considered wet. It is only when the droplet comes into the contact with a solid object that can make that object wet. In conclusion, when water can certainly make other objects wet due to its adhesive property, it is not accurate to say water itself is wet. Wetness is a property that emerges from the interaction between a liquid and a solid surface, highlighting the nuanced nature of this common yet complex concept.